In this video, I'm going to demo solving equations involving absolute value. I'm also going to write out some steps to follow when solving. So we're going to solve this one, 3 times the absolute value of n plus absolute value negative 11 equals 20. So the steps to follow would be step 1 is to isolate the absolute value of x. So you're going to do everything you can to isolate the absolute value of x or whatever the variable is without dropping the bars. Step 2, we're going to drop the bars. And split the equation. And I'll demo what this looks like in the next couple of examples. So this first step, though, is critical. We do not want to drop the bars. We want to isolate our variable. So in this case, we will keep the bars for n. We do not distribute the 3 inside. We do plus absolute value of negative 11 is 11 equals 20. So we're basically going to redo steps from 7th grade on how to isolate a variable, but we're not going to tinker with these bars right now. Next step would be we're going to subtract 11 or add negative 11 to both sides. So we have 3 times the absolute value of n equals 9. Notice that I still have not dropped the bars. If we drop the bars prior to this, we might stumble on a right answer with some of these easier ones, but it will not work for the more difficult ones. Next step, to isolate the bars, we're going to divide by 3 or multiply by a third. Absolute value of n equals positive 3. And now we're asking ourselves, what are 2 numbers that are 3 units away from 0? And there is a number that is to the left and there on the number line, and there is a number to the right. And so by splitting, I literally fork this, make 2 equations. And for this first one, we're done after we split. As they get trickier, we sometimes will have 2 separate equations that we'll solve. So we can write our answers 2 ways. We can write n equals negative 3, comma 3. Or we can write n equals plus or minus 3 if it's the same digit, but just its opposite. So a positive 3 and a negative 3. We'll look at a couple other examples of this. Next one we'll do is absolute value of x minus the absolute value of negative 17 equals positive 3. So we will work on isolating the bars. This minus sign comes down. Negative 17 becomes positive 17, but of course now it's negative again, equals 3. We add 17 to both sides. I still haven't dropped the bars. And now the question is, I'm looking for 2 numbers that are 20 units away from 0. And I split this into 2 equations, one to the left, one to the right. And that's my answer. Or I can clean it up and just put negative 20, comma 20. You can also do the plus or minus. 18. This time we have 1.2 times the absolute value of n equals 6. So we will divide both sides by 1.2. We're doing our multiplicative inverse. To undo multiplication, we multiply by the reciprocal or divide. Absolute value of n equals, so this is 60 over 12, which means absolute value of n is 5. I split, and I have my 2 equations and my 2 answers. So previous to this, when we solved equations, we either got 1 answer, no answers, or infinitely many. And now we're getting this new spot, which is that we have exactly 2 answers. Number 20, 3 minus the quantity 5 minus the absolute value of x equals 6. So the first step is we're going to apply this negative. We're going to distribute it through. We're not going to distribute it into the bars, but we're going to distribute it in front of the bars. There's a negative 1 here. Essentially, that's times the absolute value of x. And in some ways, we can think of this as a negative 1. So we're going to distribute. We get 3 minus 5 plus absolute value of x equals 6. Negative 3 plus 5 is negative 2, plus the absolute value of x equals 6. We'll do additive inverse. This problem does not have multiplicative inverse. And we split. And now we drop the bars. We have to really train ourselves. There'll be another lesson on this where the equations will become more difficult. And if we're dropping the bars too soon, then we will definitely not be getting the correct answer, especially on the last one that we're going to look at, which is number 23, which is take the opposite of the absolute value of negative a, which is equal to 11. So the first step is we're going to get rid of this negative in front. So to do that, we will divide both sides by negative 1. And that would mean that this negative and this negative cancel. I have not tinkered with the bars or whatever is inside the bars. Also, as these become more difficult, that we can't take the absolute value of this and say that this is just going to be positive a. We're going to leave this just as it is. Next step, we're going to look at this, and this is essentially asking, let's cover this up. I need a number that is negative 11 units away from 0. Doesn't matter what's inside right now. I need a number that is negative 11 units away from 0. When we wrote the definition of absolute value, we stated that it had to be positive. So that means that this actually is a no solution, or a no solution. We can also use the symbol time, that this does not make any sense, that this is impossible, that even if we tried to solve it and we claimed the answer was 11 or negative 11, if we plug those values back into the original equation very carefully, they will not check out. So one more time, the way that we now know if something is no solution is that we see an absolute value bar that is fully isolated and is equal to a negative number. So it is right before the split step.